All right. The topic that we are going to discuss now is trigonometry. Okay. In trigonometry, tri means three, gono means angle, metry means measure. So trigonometry means three angle measure. Okay. That is the literal meaning of trigonometry. It actually means the triangle. Right. So let me take a right angle triangle. Okay. This is 90-degree. And let me take this as angle theta. Okay. If I consider this angle theta, then this will be the opposite side, the side opposite to the angle theta, and the side adjacent to this angle theta is called as adjacent side, and the longest side is called as hypotenuse. Okay, so the side opposite to angle theta is called as opposite side. The side adjacent to angle theta is called as adjacent side, and the longest side is the hypotenuse. Okay, now let's say if I take this angle. Okay, if I consider angle A. Okay. If I consider this angle, then the side opposite to this angle, which is BC, will be the opposite side. The side adjacent to this angle theta will be the adjacent side. And hypotenuse will be the same side. The longest side will always be the hypotenuse. Okay? So depending on the angle, the opposite side and the adjacent side will change. Now, tell me one thing. If I say ratio of the sides, ratio of sides, okay? In this triangle, if I take ratio of the sides, how does a ratio look like? A ratio looks like this, which can be written as A by B. Now you tell me, if I take the ratio of these sides, in how many ways, can I choose the numerator here? There are three sides of the triangle. So there are three ways in which I can choose the numerator. In how many ways can I choose the denominator? Let's say if one of the sides I've selected, then there are two more ways in which I can choose the denominator. Right? So whatever side you have selected for the numerator, you'll not select that side for the denominator. Yeah. So you tell me how many ratios are possible. You tell me how many ratios are possible. Can I say 3 into 2? There are six ways or six ratios possible with these sides. Yes or no? These six ratios are called as trigonometric ratios. And what are those six ratios? Let me write them. So what are the six ratios? One is opposite side by hypotenuse. Then hypotenuse by opposite, it's reciprocal. Adjacent by hypotenuse. Hypotenuse by adjacent. And then opposite by adjacent and adjacent by opposite. Okay? These are the six ratios possible. Is there any other ratio possible other than these six? No. These are only the six ratios that are possible. And each of these ratios have a name. Okay. What are the names that these six ratios have? Opposite by hypotenuse is called as sine theta. It's reciprocal. Hypotenuse by opposite is called as cosecant theta. Adjacent by hypotenuse is called as cos theta. Its reciprocal. Hypotenuse by adjacent is called as secant theta. Opposite by adjacent is called tan theta. And adjacent by opposite is called as cot theta. So these are the six ratios possible. And these six ratios are called as what? Trigonometric ratios. These six ratios are called as trigonometric ratios. Now, understand this. I mean, first of all, you need to remember these six ratios. That's very basic in trigonometry, which you have to remember. The second thing that I want you to understand here is, you see that whatever trigonometric ratio I take, there is a reciprocal relation exists for every trigonometric ratio. So I can say, see, cosecant theta is equal to 1 by sine theta. Or I can say, see, secant theta is equal to 1 by cos theta. Or I can say, cot theta is equal to 1 by tan theta. Every trigonometric ratio has a reciprocal relation. Okay. And another thing that I want you to notice here is that if I do sine by cos, if I do sine theta by cos theta, what I will get? You see, what I have, opposite by hypotenuse and adjacent by hypotenuse, right? So hypotenuse will get cancelled. So what I will get? Opposite by adjacent. What is opposite by adjacent? Opposite by adjacent is tan theta. So I can say that tan theta is equal to sin theta by cos theta. Okay? So two things I want you to remember in trigonometric ratios. One thing is that, of course, you have to know the trigonometric ratios. But other than that, I want you to remember two things. One is that there's a reciprocal relation that exists for every trigonometric ratio. And second thing is that this tan theta is equal to sin theta by cos theta. Okay? Okay. Having understood the meaning of trigonometry and what are trigonometric ratios, let's see something called as trigonometric identities now. Okay. There are three trigonometric identities. Before seeing those I'm going to derive those trigonometric identities from Pythagoras theorem. So what is Pythagoras theorem? Pythagoras theorem says side square plus side square equal to hypotenuse square. Yeah. What is Pythagoras theorem says? Side square plus side square is equal to hypotenuse square. In trigonometry, each of those sides have been given a name, opposite and adjacent. So here I'm writing it as Pythagoras theorem as opposite square plus adjacent square is equal to hypotenuse square. Now, like I said, I'm going to do three things here. The first thing that I'm going to do is I'm going to divide this entire Pythagoras theorem by hypotenuse square. What I will get if I divide the entire Pythagoras theorem by hypotenuse square? I'll get opposite by hypotenuse square plus adjacent by hypotenuse square equal to hypotenuse by hypotenuse square. Yeah. So what is adjacent by hypotenuse? We just now saw. What is opposite by hypotenuse called as? Opposite by hypotenuse called sine theta. That is sine square theta. What is adjacent by hypotenuse called as? What is the trigonometric ratio? Cos theta. So it is cos square theta equal to 1. So my first trigonometric identity is sine square theta plus cos square theta is equal to 1. So irrespective of whatever angle you take, what is theta their angle, whatever angle you take, this will always satisfy. What is that? Sine square theta plus cos square theta equal to 1. This is the first trigonometric identity. Now, to get the second trigonometric identity, I am going to divide this entire Pythagoras theorem by adjacent square. What I'll get if I divide the entire Pythagoras theorem by adjacent square, I'll get opposite by adjacent square plus adjacent by adjacent square plus hypotenuse by adjacent square. So opposite by adjacent is what? Tan theta plus adjacent by adjacent is what? 1. Sorry, this is equal to, right? Is equal to, what is hypotenuse by adjacent? Hypotenuse by adjacent is reciprocal of cos, which is secant square theta. Okay. Now, if I send this tan square theta to the other side, what I'll get? Secant square theta minus tan square theta equal to 1. Okay. In simple equations chapter, we say that you keep all variables on one side and you keep constants on the other side, right? So here, what are the variables? The trigonometric ratios are the variables. So what am I doing? I'm keeping all the trigonometric ratios on one side and I'm keeping the constant on the other side. Okay. That's my second trigonometric identity. To get the third trigonometric identity, what I'm going to do? I'm going to divide the entire Pythagoras theorem by opposite square. What I will get if I do that? Opposite by opposite square, which is 1. Adjacent by opposite square, which is cot. And hypotenuse by opposite square, which is cosecant. Again, if I bring all the trigonometric ratios on one side, what I'm getting? Cosecant square theta minus cot square theta is equal to 1. So we have three trigonometric identities. Sine square theta plus cos square theta equal to 1. Secant square theta minus tan square theta equal to 1. And cosecant square theta minus cot square theta equal to 1. Okay. So there are total 6 trigonometric ratios. There are total 6 trigonometric ratios. And there are total 3 trigonometric identities. Okay. All right. Let's see an example now on this. If sine theta is equal to 3 by 5, find the other trigonometric ratios. Okay, so he has given you the sine theta and is asking you to find the other trigonometric ratios. Okay, and when sine theta is given to you, the first thing I can say that cosecant theta is equal to 5 by 3. It's reciprocal. Its reciprocal is cosecant theta. Okay, so out of 6 trigonometric ratios, I got 2. To get the remaining 4 trigonometric ratios, what I will do, I will draw the triangle. Okay, so this is, let's say this is theta. Okay, this is opposite side, this is adjacent side, and this is hypotenuse. What is the opposite side? 3. Hypotenuse is 5. So if opposite side is 3 and hypotenuse is 5, right? So 5, you apply Pythagoras theorem, 5 square minus 3 square, 25 minus 9, square root of 16, you'll get 4. Right? Adjacent side is 4. Now, here is important, theta is acute angle. Okay, we'll discuss this later, why theta should be an acute angle, but if theta is an acute angle, okay, what will happen now? You can, by Pythagoras theorem, you can put this as adjacent side as 4. So what is cos theta? Cos theta is adjacent by hypotenuse, which will be 4 by 5. If cos theta is 4 by 5, then secant theta is what? 5 by 4. Next, what is tan theta? Tan theta is sine by cos. What is sine 3 by 5? What is cos 4 by 5? So 5 will get cancelled. What I'm getting, tan theta is 3 by 4. So if tan theta is 3 by 4, what does that mean? It's reciprocal. Cot theta is 4 by 3. Okay? So given a trigonometric ratios, how to find the other trigonometric ratios is what we have seen. Okay? So I hope you're clear with what trigonometric means, what is trigonometric, what are trigonometric ratios, and what are the 3 trigonometric identities here. Okay?